G'day. My name is Christian Monopol, and today we'll be showcasing how Interset can be used to automate UEBA use cases and their resolutions inside organizations. I'm from an organization called Secure Identity Technologies, and with me I have Brendan Meyer, one of our senior consultants that is well versed in communicating UEBA and the respective MITRE ATT&CK use cases in environments today. And on an additional note, we as Secured have actually also been instrumental in the bringing the Interset product sets and Interset functionality into the South African and African market. We also have one of the first live POC environments where clients can actually engage with us directly due to the complex nature of big data they can actually consume upon our own POC environments. Now, what we will be covering today is a couple of topics. First and foremost, ArcSight Intelligence and Micro Focus Interset is for all intents and purposes the exact same product. ArcSight Intelligence is just used with ArcSight combined branding. So if you actually procure Interset along with the ArcSight product stack, it's defined as ArcSight Intelligence, and Micro Focus Interset if it's procured separate to ArcSight for either uses with existing SIEM solutions or uses where it's actually standalone. We will also be taking some live data views out of a demo system and presenting that today. We'll try and actually present it in a contextual format so that it can be readable and then also be explained in the correct way. We'll be covering the Interset concepts where the normalization of big data into human readable format so that SOC operators, Security Operations Center operators, can actually act on real risks. We'll also demonstrate the MITRE ATT&CK framework, how that is used to automate specific at-risk use cases, and we immediately notify the operators and the teams of those use cases actually being considered. In our demo environment, we have roughly about 1.8 billion events, and from our use cases, we can actually condense that into 22 risky entities inside the organization. And today's demo session will focus on one specific entity that has suspicious activity on it, and how you can actually drill into that data and immediately act upon it. Lastly, we'll also be talking about integration of identity and access functionality into a UEBA solution, and also access and identity solutions consuming UEBA solution outcomes, where Brendan will discuss and show to us how at-risk data or at-risk entities that reach a specific risk scoring will be prohibited from authenticating into specific resources based on the automated risk scoring levels that he's reached inside the organization. Right, on to Brendan, who will show us the way.
And show you how we integrate into our solutions to reduce risk and help our customers around the world. With a growing number of threats to monitor in the IT ecosystem, IT organizations have a demanding need to continuously think of better and effective ways to secure their enterprise network. In today's world, employees can access their company data and applications from within the company, from home, or even through personal mobile devices regardless of their geolocation. So organizations have to manage their assets both on-prem and in the cloud environment. And it has become increasingly challenging for their IT security teams to detect any malicious activity carried out by these internal users, be it intentionally or accidentally, such as theft, data exfiltration, and account compromise. Now, yes, you might have a SIEM solution. These SIEM solutions traditionally offer security and compliance monitoring that focus mostly on external threats. Now, today's organizations need solutions that also perform in-depth user behavior monitoring that can detect anomalies and potential threats happening within the organization. Now, most of the data loss and data breaches activities that we've seen are carried out by users with privileged, valid credentials. So, how do we address these risks? Well, let me introduce you to Oxide Intelligence. Oxide Intelligence is a UEBA solution that gives your security team a new lens to find and respond to unknown threats before data is stolen. Oxide Intelligence is powered by 100% unsupervised machine learning and makes use of more than 450 threat detection algorithms. These algorithms measure the unique digital fingerprint of your systems and users and are aligned to the MITRE ATT&CK framework and allows Oxide Intelligence to filter through billions of events and distill these events into a handful of prioritized threats. So before I show you how Oxide Intelligence looks and feels, we need to understand how it works. We start this journey essentially by collecting contextual data and assigning a risk score to the data. This data is essentially collected from multiple sources, be it your AD, be it your endpoints, repositories, web proxies, databases, and even your in-place SIEM solutions. This allows us to get a full 360-degree picture of your user's behavior. Now, Oxide Intelligence correlates the user's behavior and creates a baseline. This baseline is then used to compare a user's behavior to a user in his her group to find what is common for the specific user and what is common for the users in this group. We finally transition to the detection phase. Now, this is where we look into deviations in a user's behavior and essentially flag these anomalies. Now, anomalies will then automatically increase a user's risk. Now, one thing to note here is we do not take any action at this point. We show you the riskiest users, we show you the highest risk and the lateral movement inside the organization, but we do not take action. Now that's the core of what the session is about. Today we'll show you how we integrate into our access management solution and how we make use of our UBA service essentially as a risk service to define rules inside our access management to allow or deny or step up authentication. So I'll start off by just showing you a quick overview of the landing page. We'll then move into some use cases and we'll then take it from there. So over here on the landing page, when you log in, first thing you see is the big amount of data that we've analyzed. You can see 1.8 million events that we have analyzed inside our Oxide Intelligence environment. Of these 1.8 million events, we have found 503,000 anomalies and violations. Now this comes from multiple sources. You can see the sources just below that: users, machines, controllers, IP addresses, websites. Now, of these 503,000 anomalies and violations, we have identified 22 risky entities, be it a thing or a user, but these have been identified as risky. We also have a nice view of the lateral movement over a period of time. And my favorite part is to show you the top 5 riskiest users. Now today we'll dig into these top 5, or essentially the top 1 user, Mr. Joshua Newman, and we see how his data looks and the use cases Oxide Intelligence addresses. Okay, so we start our use cases off with initial access. Notice on the left corner here, left hand corner at the bottom, how we make use of the MITRE ATT&CK framework to show each of the use cases and how we go through this cycle. The first part is Joshua Newman's a normal user. You'll notice from the events that he tried to get access to the network IT share. Now, a normal user is not supposed to get access here. This is typical when an attacker is trying to exploit more information, be it from specific code that's stored in your IT share or IT project and related information. Now this is rare access. We can also see abnormal working hours for Joshua Newman. Suddenly at 3 a.m. in the morning he's working, where his normal working hours is between 9 a.m. and 6 p.m. The same from a working day perspective. Suddenly he's working on Saturdays. Now this then leads us up to the next part, the execution phase. Now the execution phase is essentially where the attacker is preparing for a future attack. Now we've know the initial access shows us the attacker has gained access. Now Joshua Newman's account suddenly starts running authentication service applications and VM tools and a Windows update, which is abnormal for a normal user to run. Now, as mentioned, this is all in preparation for the future attack that this attacker is planning. So now we move on to the privilege escalation phase. Here we can see how this attacker is trying to bypass or circumvent existing controls. Be it that Joshua Newman's account does not have enough access, but here he's trying to run a few programs to try and escalate his privileges to be able to do more when he plans to attack the organization. Here we can see the credential access phase. At this point in time, we've now seen initial access to the organization. We've seen execution of applications. We've seen the attempt to get privileged escalation going. We now see Joshua Newman trying to attempt more than 45 times in 1 hour to get access or log in. And this is abnormal for him to do. We then also see this attacker finally get access to the domain controller. Now, why would you go to the domain controller? Why would a normal user go there? And my best guess over here is that the attacker is trying to get and collect more credentials from the domain controller and also poke around to see what other vulnerabilities they can find inside the organization. And this essentially is us to show how more suspicious failed login attempts are being attempted by Joshua Newman's account. Now, this brings us then to the discovery and lateral movement of the attacker. Now, this attacker is now starting to dig around for more information. He's now accessing 19 unique projects in 1 hour. Why would anyone be wanting to look through 19 different projects in an hour? The same from the next part is this attacker is now suddenly looking at clients' data. Now, it doesn't show it yet, but if you drill down, it's essentially credit card information he's trying to access over here. And then finally, if it is defined, and a lot of organizations have intellectual property, and once defined, Oxide Intelligence can then also show you when a user accesses their sensitive projects or sensitive data. This then brings us to the command and control phase. Now, the command and control phase is essentially the attacker that wants to ensure communication of the assets for future use. So there's many examples inside Oxide Intelligence, but here's a one where Joshua Newman's account is currently making use of the RPC over HTTP capabilities. Now, you get the request method RPC in data and then obviously the out data, and that essentially allows the attackers for two-way communication for future use. Make sure that we can communicate from the compromised side to their side to transfer data for the next phase. Now, data exfiltration is essentially when your data is now leaving your organization. Now, here we can see Joshua Newman's account sent 1.3 gigabyte data to a proxy service on initial first access, and then after that more than 700 meg for an hour to a suspicious website. This is now your data leaving your organization and getting into the hands of attackers to essentially exploit your organization. So we've now seen extremely useful information to show you what you are at risk at inside your organization. But now, how do we take control of the risk? This is where we do the integration part of our solutions, be it Advanced Authentication, Access Manager, Secure API Manager, Privilege Account Manager, and we integrate it into our risk service. Now we've built this risk service risk engine around the need for organizations to implement behavioral adaptive access. This is essentially access control tailored to a user's behavior, all while no predefined rules had to be specified. It simply learns as it goes. This risk service consumes a list of contextual parameters of a user during the first login. Now, Oxide Intelligence then determines the user's risk and then tells the consuming product what the risk is of the user. So, for example, with Access Manager, it will add a step-up authentication if a user's risk is high. With Advanced Authentication, it will change the authentication method based on risk. For example, low-risk user will log in with a username and password, while a high-risk user will be username password plus biometric authentication. The same will happen with our PAM and Secure API Manager to assess a user's risk and essentially define how that user needs to be handled. Okay, so let's jump into another use case example, and this is now us preventing malicious access. So here we have Joshua Newman. He's a healthcare rep. He loves browsing the web and news blogs from his work computer. Now, one morning, he inadvertently clicked on the malicious URL and it injected spyware script in his browser. Now, we suddenly see the same user risk activity happening as we saw in a use case. Unusual working hours, suddenly large number of sensitive applications access, a massive amount of authentications and success and failures, and we pick up lateral movement. Now this all increases his risk, and in a normal environment or a normal use case, you would now have known is at risk. But now we're going to make use of our access management solution to block him based on his risk. So let's jump into our live demo here. So first things first, we need to now show you what access would look prior to our risk engine that's been executed, or the risk view being executed. So here we now log into Joshua Newman's account. It prompts us for a second factor. As a normal user, currently there's no risk engine enabled at this point in time. We log in normally, no problem, even though an account has been compromised. Now here we can see everything normal, everything is perfect. You can get access to all these web applications, not a problem. So let's jump into where we define it. So from Access Manager perspective, here we can then navigate to the behavior analytical engine or analytics, and this is where we then enable the integration with Interset or Oxide Intelligence. Currently it's a base URL which is on the AWS S3 tier, and we then specify the region and an access key with a security code. This then allows us to communicate to our risk engine. Now, the only assumption we really take here is that a Oxide Intelligence instance have been installed and is ready for you to then consume from our access management solution. If you want to then also send audit event data, you're then more than welcome to just make use of the Oxide receiver, and that will then allow you to configure audit event data to be sent through. Obviously just specify the certificate that is then required. Okay, so you can see we've enabled the integration, and there will now be a rule automatically created, behavior analytical rule, and this is just a rule that automatically gets created for the integration. Now over here we specify the source URL, and you can specify the authentication type. In our use case, it's inside the organization. You can also then look at the parameter value. Now the parameter value is essentially the percentage. So if a user's risk is above 50, this rule will then kick off. No other parameters can or should be changed here. We then look at the risk policy. Now this is the policy that then now defines what needs to happen once a risk is higher than 50. So here you can see behavioral analytical rule. Once it's been picked up that the risk policy is over 50, it will deny access. That then essentially gives us our rule. So next step, let's quickly log into Joshua Newman's account again. So let's log out and we will log in again. This time Joshua Newman's account will be subject to our user entered behavior analytics risk policy. And lo and behold, you can see us getting an access denied. Suddenly we have actioned on the risks that we are seeing in Oxide intelligence, and we can now stop access being given. So let's quickly just jump into the Oxide intelligence dashboard and dig into Joshua Newman's account. So here you'll see the dash again, all the event data, all our sources, and then obviously the timeline. And at the bottom, click on Joshua Newman's account, and this will then allow us to dig into his account a bit better. Now we can see the whole timeline that led up to his existing risk score. As you can see, it's quite high, it's at 98. And here you can dig down into the events. Here we can see a incident with a high number of logins, 1.5 times in an hour. The same at the bottom there. And this all then allows us to build more information around Joshua Newman's risk, and then essentially use this to be used in our PAM, access management, and IGA solutions in future. Now, here we can also see then the lateral movement over a period of time, the privilege escalation, the initial access, the exfiltration, the credential access, all shown in our use cases during the start of the session. And this all then provides extreme valuable information, not just from a view perspective. Now you're not seeing just the risky user, we're also then actioning and enabling an organization to action on users or high risk users inside the organization. So that then essentially concludes our session, and I hope you have had a wonderful time. Have a lovely day. Thank you.